Here we have a system of linear equations. Now there are different methods and different ways to tackle this, but we're going to solve it using substitution. So let's jump right in. The first thing we try to do is we try to isolate a variable and we try to solve for that variable. So solving for this plain x is going to be the easiest because if I'm trying to solve for 3x, I have to divide this by 3 and all that side by 3 and it gets more complicated, right? So let me rewrite this as x plus 4y equals 6. Now to solve for x, I'm going to subtract 4y from this side, and anything I do to one side, I must do to the other side. So I'm going to go minus 4y over here as well. These cancel out, and I'm left with x equals 6 minus 4y. So this right over here is the value of x. All right, that's going to be our x value. Now, since this is our x value, we're going to input it into this second equation every time we see an x. So right over here, I see an x. So instead of writing just an x, we're going to input these numbers. So let's go ahead and do that. 3 times x is 6 minus 4y. And then we're going to go minus 5y equals negative 16. All right. Let's go ahead and distribute this 3 to every number in here. 3 times 6 is 18. 3 times negative 4 is going to be negative 12. So negative 12y minus 5y equals negative 16. We want to get all the variables on the left-hand side and all the numbers on the right-hand side. So over here with this 18, we need to subtract this 18, get it out of here. And then anything we do to one side, we must do to the other side. That cancels out. We are left with negative 12y minus 5y equals negative 34. All right. What is negative 12 minus 5? That'll be negative 17. So we're going to write in negative 17y equals negative 34. Now we need to divide both sides by negative 17 in order to isolate that y. So we divide both sides by negative 17. We are left with y equals 2. Y equals 2. All right, so this is the answer for y. So now that we have y solved, we're going to go back up and see what the x value was. X was this right over here. X was 6 minus 4y, and now y equals 2. So what we're going to do is over here, we're going to rewrite our x value, and we're going to input our y value. All right, so we're going to go x equals 6 minus 4y. X equals 6 minus 4y. That was our previous x value. Now we're going to input the 2 in there, so we're going to go x equals 6 minus 4 times 2. 4 times 2 equals 8, and 6 minus 8 is negative 2. So x equals negative 2. And just like that, we have solved for x. X now equals negative 2. Now these two equations, 6 minus 4y and x equals negative 2, they're equivalent. This is just a longer way of writing it when you do not know what y equals. But the reason why we did this is so that we could input it into that second equation and be able to solve for y. Now we're going to write the answer as an ordered pair. So I'm going to write this. The x value always goes first, negative 2, and then the y value goes next, positive 2, and that right there is our answer. All right, so now let's do another example. Same thing, I take a look and I'm trying to find the easiest variable to solve for. And over here I see 5x, I see a plain y, so that's a good option. I see a 2x and a negative 3y. So this y right over here is going to be the best option to try to solve for. So over here I'm going to write 5x plus y equals 4. And in order to isolate that y, I've got to subtract 5x from this side. And anything you do to one side, you must do to the other side. Those cancel out. I am left with y equals 4 minus 5x. So this right over here is our value for y. And just like in the other example, we're going to use this to solve for x. Now we're going to go to the second equation right over here, 2x minus 3y equals 5. Every time we see a y, we're going to input these numbers in order to solve for x. So let's go ahead and write that. 2x minus 3 times y, and y is 4 minus 5x, equals 5. All right, so now let's distribute this negative 3 into every number in here. So we would write 2x, and negative 3 times 4 is going to be negative 12. Negative 3 times negative 5x is going to be positive 15x, so plus 15x. And then we've got equals 5. Now again, we want to get all the variables on the left-hand side and all the plain numbers on the right-hand side. So over here I see a 12, negative 12. So to get it out of here, I need to add 12. So let's go plus 12 and plus 12. These cancel out. I am left with 2x plus 15x equals 17. Now the next step is pretty easy. 15 plus 2 is 17x, so 17x equals 17, and this is looking pretty easy now. These cancel out, and x equals 1. When a variable equals 1, I think all that work for it to equal 1, right? You want it to be a nice big number, right? But x equals 1. All right, so now we know that x equals 1. That's the answer for x. Now let's go back to our previous answer for y. Y over here was y equals 4 minus 5x. All right, so let's rewrite that. Y equals 4 minus 5x. Y equals 4 minus 5x. Now let's input our newly found value for x over here. So this is going to be y equals 4 minus 5 times x equals 1. So it's literally the exact same thing. Negative 5 times 1 remains negative 5. So it's just going to be y equals 4 minus 5. And 4 minus 5 is negative 1. Negative 1. And so we know that y equals negative 1. And that right there is the answer for y. Now we've solved x, and now we've solved y. Now let's just put them as ordered pairs. So the x value always goes first, and then the y value goes next. And in parentheses, this right over here is our answer. 1, negative 1. Now, like I mentioned in the beginning, there are many different methods for solving a system of linear equations. This one's substitution because we substituted this value into the next equation. The substitution method is very useful when we take a look at our system of linear equations, and we see that one of these equations has a plain variable, like just a y, without a 3 in front of it, without a 5 in front of it, or any of that stuff. So it's very easy to use substitution when we see that there's just a plain variable like that. If you look at it and there are no variables that are just by themselves, many times we'll use elimination. But that's for a different topic. So today, it's substitution. And I hope this video was helpful, helped you understand how to solve a system of linear equations by substitution. And as always, stay positive.